All right, do this right away first before I get into what I'm going to do. I'm not going to need a lot of room, like 2 lines. But you don't need your iPads right now. You guys don't have them on. Mark down those 5 little problems I got going across the front of the board right now. Just mark them down. Not that stuff over here, just 1, 2, 3, the 5 little problems there. And as you're doing that, I'm just gonna, I guess you're gonna hear it all week. If you do not know your special angles, you've heard this song and dance 1,000,000 times. You ain't gonna be able to do these. If you don't know your special angle values, you're screwed. You ain't gonna be able to do anything. And you've heard that 1,000,000 times before. Yesterday, I just went over inverse sine and inverse cosine. Now you can see what I'm gonna do here. I'm going to go through the inverse of the other ones. Inverse tan, inverse cotan, inverse secant, inverse cosecant. Now watch this. It's going to be very, very similar. And I'm going to give you the easiest way to learn this. Now let's see if you can just remember from what you just turned in. If you have inverse sine, somebody, where's the only place the answers could possibly be? This is the whole key to inverses. You can't screw up where the answers could be. If it's arc sine or inverse sine, the answers can only be, Ethan, 1 or 4. And if it's inverse cosine or arc cosine, it's 1 or 2. You can't forget that. Now I want you to look at the handout I gave you. You don't have to write on it, just look at it. There's inverse sine and cosine written again. Now look at secant and cosecant. They pretty much look the same, almost, don't they? Let's look at them. You see the range for cosecant? Isn't it the same as it was for sine? Remember, cosecant's reciprocal to sine, and secant's reciprocal cosine. Do you see the ranges there are the same, but there was only one thing added? Now, do you have your chart there? The one I printed up for you real nice? You see where it says, in inverse cosecant, it says y cannot equal 0. You see it on the handout? Why? Look at your chart. Isn't inverse cosecant exactly the same as inverse sine? But look at the hand that I just gave you. It says y cannot be a 0. Why? Look at your handout from yesterday. Joe, it's undefined there. It's the same, but it can't be a 0. Look at number 4, inverse secant. It says y cannot be pi over 2. Now where's pi over 2? It's 90, right? Why can't it be pi over 2 for secant? Well, the secant of 90 is undefined. Now, look at inverse tan and cotan. Inverse tan, well, let me ask you, what's the only thing different in inverse tan from inverse sine? Look at it closely on the paper I just gave you. What's the only thing different about inverse tan compared to inverse sine? Just look at the handout I gave you. What's the only thing different? What's the only thing different? There's but one small difference. What is it? Jimmy? Doesn't include the negative pi over 2 and the positive pi over 2. Isn't negative pi over 2 negative 90? Isn't pi over 2 90? You know why it doesn't include those? Because at those values, tangent is undefined. Same reason. And look at inverse cotan. Isn't it the same as inverse cosine? But it doesn't include 0 or pi because those places are undefined. Now, you're going to want to mark this in your notebook. Here's the easiest way to remember all of this for inverses. I'm going to give you a little chart here. You're definitely going to want to write this down. If you have sine cosecant, or tangent. Now, sine and cosecant, those are reciprocals, right? So they're going to go together. Or tangent, where's the only place those answers could be for inverses? You could look on the handout if you have to. Quadrants, fellas, quadrants. Inverse sine, inverse cosecant, or inverse tangent. Where's the only places those answers could be? Howard?
1 and 4.
Okay, I'm going to put a, okay, go 1 and 4. And it's inverse cosine, inverse secant, which is a reciprocal, inverse cotan. Those are 1 and 2. Now, I think this is the easiest way for you to learn all this. In other words, you see this big handout I just gave you? Wouldn't that little diagram kind of summarize the whole piece of paper? Think about what I'm saying here. Wouldn't that be the easiest way for you to learn this? You certainly don't want to mix them up. So sine, cosecant are reciprocals, they go together. Cosine and secant are reciprocals, they go together. Tan is up here, cotan is down here. The only thing for these three is there might be places where it's undefined. It's the only difference. Now, look at the 5 problems on the board. You got your chart there. You're going to do these exactly the same way as the homework you just turned in. It's just going to be inverse one of the other ones. Now, what did I tell you yesterday is the first thing you have to write down right away. This is the same as yesterday. And I hope you did it on your papers. Pay attention here, because yesterday and today's class are key for the rest of the stuff for the rest of the week. David.
Tan of y equals 1.
Okay, now in your notebook, go ahead. Tan of y equals 1. You got to write it down. And then this one will be what? Secant of y equals 2. This one. Cosecant of y equals negative 2 radical 3 over 3. This one. Cotan of y equals radical 3. This one. Secant of y equals negative radical 2. So your first step is exactly the same as yesterday's. Now, boys, please, this is the easiest way I could teach this. If you know your special angles, to get those answers is going to be just the same as yesterday. Here's another thing for you to remember. I don't care which one of these 6 you have. If the value's positive, it's always going to be in quadrant 1, right? If it's a positive value, it's always going to be in the first. Unless it's a quadrant angle, which some of these are. So this is obviously the first quadrant here. This is obviously the first quadrant here. Okay, now here's where you got to be careful. I'm not going to say anything. What quadrant does that one have to be in? Now, boys, please, this is all you have to know here for today. Right here. This summarizes it very nicely for inverses. In what quadrant for the third one would the answer have to be? Rob? Fourth. Because cosecant's the same as sine. See? 1 or 4. So this one has to be in quadrant 4. This one obviously has to be in quadrant 1. Okay, what about that last one? Secant of y equals negative radical 2. Where's the answer got to be? And here. Negative's got to be in 2. Now, does anyone have a question on that first? Because I saw a paper this morning, and some people are writing the answer in the first quadrant and in the first quadrant because it's negative. So the question is, the tangent of what angle equals 1? You know your special angles, this is a piece of cake. If you don't, it's not going to be. So take that for what it's worth. Max?
45 degrees.
45 degrees. So you would say y equals 45 degrees, or if the direction said radians, what would that be? Remember the homework you did? Some said degrees, some said radians. If it said put it in radians, what would the answer be? Gotta know your angles. Quick.
Power 4.
Power 4. This one. The secant of what angle is a 2? And remember, secant is reciprocal of cosine. All right, you know what I want to say? Please, listen, hi, Father. Let me just say this. When you guys take tests, I know what a lot of you do, because I see your papers. You know, you draw the little triangles, or some of you actually write the chart out. How many of you do that? I mean, I've been seeing your paper. Okay, now I'm begging you guys. I don't care if you do that. You got to make sure you're writing the right numbers down. If you like redo that chart when you take the test, and there's stuff wrong in it, you're kind of screwed. So just make sure you're doing that correctly. The secant of what angle is a 2? What's the angle, Jim? 60. Or if it said radians, you would say, got to know them both ways. No.
Power 3.
All right, look at the next one. Now, be careful here. The cosecant of what angle first has a value of 2 radical 3 over 3? First, give me the angle. The cosecant. What's the angle? What's the angle for cosecant for 2 radical 3 over 3? Ethan. Okay, it's 60. But the answer to that is in the 4th quadrant. How are you going to write the answer? Be careful here. This is where people make mistakes. How are you going to write the answer to this? Because this is in the 4th quadrant. What are you going to put for that?
Would be negative 60.
Negative 60. Don't go all the way around. Negative 60 or radians. Come on.
Negative power 3.
Okay, look at the next one. First quadrant. Wouldn't you say they're easier if they're in quadrant 1? Those are the easier ones, right? Which is whatever it is. Cotan of what angle is radical 3? What's the angle? Cotan of what angle is radical 3? David? 30. Or radians is Adam? Pi over 6. The next one. First, now look, this is quadrant 2. But guess what? You can't give me the answer in quadrant 2 until you know what that angle is, the reference angle. What's the angle associated with radical 2 for secant first? You have to reference angle. What's the angle associated with radical 2 for secant? What is it? What's the angle associated with radical 2 for secant? Andrew. Okay, that's not the answer though. This is quadrant 2. What's the angle in the second quadrant that has the 45-degree reference angle? John?
135.
135. Gotta know your special angles. Now, or, what if that said radians? 45-degree increments is so many pi over 4, right? Howard?
3 pi over 4.
Now, let me step back for a minute. Please, who has a question what I just did? I think you would agree if you know your special angles, it's not that hard. Now, I'm not done yet. See this right here? Worksheet number 1, those numbers, that's what that is. It's going to be the tan, the cotan, the secants, and the cosecants. Now, write this down. Now watch how I'm going to change the problem here.